Okay, so this lesson is about applications of exponential and logarithmic functions. So we're going to do some word problems here. So the first one says, if I sub 0 and I denote the intensity of light before and after going through a material, and x is the distance in feet the light travels in the material, then according to the Beer-Lambert law, negative 1 over k natural log of I over I sub 0 equals x, where k is a constant depending on the type of material. So the first part of this problem wants you to solve for I. Now, I is right there inside the log function, so we're going to have to get it out of there. So we're going to use some of the rules we have learned. So let me rewrite the problem here. So in order to simplify this, the first thing we want to do is get rid of that negative 1 over k in front of the natural log, because we want the log to be by itself when we simplify it. So the first thing we want to do is multiply both sides by negative k. Okay, so on the left side, the negative 1 over k will go away. So we just have ln of I over I sub 0 equals negative kx. Okay, so now that we have the log by itself, we want to get rid of it. So we're going to apply e to both sides. So we're going to raise both sides by a base of e. Okay, so you could see the e and the natural log cancel each other out. So on the left side, we have I over I sub 0 equals e to the negative kx. There's one more step, which is to multiply both sides by I sub 0, because we want to solve for I. So we get I equals I sub 0 e to the negative kx. Okay, so that's part A. In part B, we're actually going to use what we just found. So in B, we're starting with that equation, I equals I sub 0 e to the negative kx. And part B says for a certain lake, k equals 0.025, and the light intensity is I sub 0 equals 14 looms. Find the light intensity at the depth of 20 feet. Okay, so we have I equals I sub 0 e to the negative kx. And we're going to plug in the information from the problem. So we know that I sub 0 is 14. Then we have e to the negative kx. So we have k is equal to negative 0.025. And then we have the depth is 20 feet. So that's our x. So it's just a matter of plugging it into the calculator. So the answer to this problem, it's about 8.49. So the light intensity at the depth of 20 feet is 8.5 looms, approximately 8.5 looms. Okay, so the second problem, a sum of $5,000 is invested at an interest rate of 5% per year. Find the time required for the money to double if the interest is compounded according to the following method. So the first one is semi-annually, so that's twice a year. So remember, our equation for this is A equals P times 1 plus R over N to the NT, where N is the is the number of times that it's compounded, R is the rate, and T is the time. So let's plug in what we know. So we have $5,000 is the principal. It's the amount we put in to the account. We have 1 plus, the interest rate is 5%, so 0.05, over 2, because it's compounded twice a year, semi-annually. And that's going to be 2 to the T. And we want to figure out when this is going to double. So when is this equal to 10,000? Okay, so let's solve this problem. So the first thing I would do here is divide both sides by 5,000, because we want to isolate the exponential part. So we're going to get 1 plus 0.05 over 2 to the 2t equals 2. Okay, so now we want to figure out the time. Now the time is right there in the exponent, so we need to get to that. And in order to do that, we need to apply log to both sides, because we want to get to that exponent. So let's apply natural log to both of these sides. Actually, let's go with the common log here. Now, one of the rules that we have learned is that we can take the exponent when we have a log, and we can put it in front of the log, so right there. So that's the rule we're going to apply here. So we're going to get 2t log of 1 plus 0.05 over 2 equals log of 2. Now both of those are base 10. Okay, so the next thing, the stuff inside here, inside the log, I'm just going to plug this in the calculator and figure out what number that is. So just to make my life a little easier here. So we have 2t log of 1.025 equals log of 2. So I'm going to divide both sides by log of 1.025. And actually, at the same time here, we could also divide both sides by 2. So we just kind of do it in one step right there. So we figure out t right away. So t equals, now plug into your calculator, log of 2 over 2 times log of 1.025, and that comes out to 14.04 years. We're going to compare that to when our interest is compounded continuously. So again, the principal is 5,000, but now we're using the base e, because remember that's our formula for continuous growth. So 0.05 is our rate times t equals, again, we want it to double, so we have 10,000 at the very end. So again, start by dividing both sides by 5,000. So we have e to the 0.05 t equals 2. Now we apply the natural log to both sides. So this side, these are gone. Divide both sides by 0.05. So t equals ln of 2 over 0.05. So time is approximately 13.86 years. So there's definitely a little bit of a difference of a few months of how long it takes to get to 10,000 when you compare the two.